Hello, today I want to go over the model more quickly, the math model, but more in detail, the Excel part of this cash flow problem that we saw in class together. So just to recall what the problem is about, we have an initial amount of money and we want to work with this money for 6 years so that ideally we want to end after 6 years with $75,000, but if that's not possible, let's try to maximize how much we can end with. If we begin with $50,000, operate over 6 years by investing and reinvesting in these 4 investments here. And we'll keep track of these investments and when we take money out of them and put money back into them through the period of 6 years. And then later, we're going to look at a couple of variations that you're going to need for the homework, which are, what if I give you a fixed ending amount and an unknown beginning amount, which you would borrow, for example. So you want to borrow the least possible so that you end up with what you need. And the other variation is, what if, in addition to the investments and reinvestments, we have intermediate outflows or inflows of cash happening along the way. So in class, we together wrote the mathematical model for this problem. And the idea was we create one variable for every investment, an A, a B, a C, and a D variable, and they are indexed by the years when I can invest in that investment. And based on the story, there are some years that are not available for some of the investments, and that's why we omit some of these. For example, there's no B3 or C1, all right? So the idea is this. There is one constraint for every year in the horizon, and the pattern that these constraints follow is this. We have a have part, that is, how much money do I have in hand at that moment, minus, then there's a spend part, equals what's left. So the pattern is whatever I have minus what I spend equals what's left. So let's see, for year 1, that means I have 50K to begin with. I'm going to spend that on all the investments that I can do in year 1, which are ABD. If I use it all, there's nothing left, so this L amount will be 0. If I don't use it all, maybe I hold on to some of that money, that amount will be in L1. So then a year goes by, because we're taking action once a year. And after 1 year, what do I have in hand? Well, I have that L1 that I just saved, let's say, under my couch at home. And a year later, I can get money back out of the savings account. But I can get the whole principal plus 5% interest. The money I put in B and D is still locked in because of their maturities. So this part here, L1 plus 105A1, is my have of the beginning of year 2. And then I'll invest again, so I'll spend in A, B, C. Those are the investments that have a subscript of C available for them. And then if there's anything left, that's L2. So 1 more year goes by. What do I have in hand? I have the L2 from last year. I have the savings money from last year that I can get back. And from 2 years ago, I have the money that I put in B, count backwards, 1, 2. 2 years ago, I invested in B1. So 2 years go by, 1, 2. I get that whole B1 amount plus 13% interest. So these first 3 terms here are my have of the beginning of year 3. And in year 3, I can invest according to the story in investments A and C. And I keep going like this all the way to the final year when I just collect things, don't invest in anything. And that's my final leftover. Because I want to end with as much as possible, my objective function is maximize L7. All right, so let's put this in Excel. As we have been doing in class, I'm creating a cell in Excel for every variable, in this case for every investment. I put them vertically like this because I want to have a horizontal passage of time from year 1 to year 7. These numbers here in the middle, right, in rows 5 through 18, they are in their particular locations because I'm representing them like this. For a given investment, let's say A1, when is it that it's an out of pocket for me? It's out of pocket at the beginning of year 1, so it's a -1 there. And it's back into my pocket a year later as the original amount plus 5%. So you see, this is basically saying in the year 1 constraint, the A1 variable will have a -1 in front of it. Is that true? Let's see. Yeah, in year 1, the A1 has a -1 in front of it. And in year 2, it has a plus 105 in front of it. And that's why I have a plus 105 in front of it here in year 2. So if you notice, every investment variable appears twice in the math, once as an out-of-pocket and once as an back into my pocket. So for example, let's look at a B investment. B1 is out of my pocket in year 1, but back into my pocket 1, 2, 2 years later, beginning of year 3, as the original principal plus 13%. And so this is the logic behind where I placed each of these numbers that are in this portion of the sheet. Okay, great. The nice thing about this is that if you do that, not only it helps you see what's happening, but it also helps you write the formulas. If you recall, we have these 7 leftover amounts, L1 through L7, right, in the math. I'm going to make room for them in Excel in this row 19. So here in row 19, these 7 cells will be my 7 L's. So in this particular cell here, I want to have whatever L1 is according to the math part. But see if you agree. Well, it is my 50,000 that's here minus A1 minus B1 minus D1. If you go back and look, you'll see that that's what it is. Well, because these minuses are in front of the A1, B1, and D1 in this column, if I sum product column B and column C like this, and let me anchor this block here, and you'll see why in a minute. So put dollars in there. If I sum product these two columns, you will see that what this does is it throws away all the investments for which I have empty cells in column C and just keeps the A1, B1, and D1. And notice I did plus sum product because the minus is already here. Right? If I put minus in front, I'm going to be minus becomes positive. So this formula that I just typed in Excel produces exactly what is this first definition of L1 here according to the math. It's 50 minus A1 minus B1 minus D1. And because the rest of the numbers are in the correct positions, if I simply drag this formula over to the right, it will produce all of the other formulas, especially because of the following. Notice that when in the math, L2 needs L1, right? Every L needs the L before it. And you can think of the 50,000 as an L0. What is it that I had before year 1? So I strategically placed this 50,000, the original 50,000, to the left of the L1 cell, because now when I make this formula, I'm making this cell C19 look back at B19 to grab that 50K, which means when I copy it, my cell D19, which is L2, will look back to C19, will look back at L1, and it needs to, right, according to the math. So the location of that 50 was strategic. Now let's copy this over. Once I do that, I'm basically finished, because this is it, right? I have defined all my L's. The only constraint I need to impose inside the solver window is to say, I don't want any of these leftover amounts to be negative, because that would mean I am spending more than what I have at some point in time, and that's not okay. So let's go inside the solver. Data here. We have to tell it what my objective cell is. Well, what I want to maximize, according to the math, if you recall, is the value of L7. So that's my set objective cell, I19. It's a max problem. My variables are going to be the investments from B5 through B18. Great. And for constraint, as I indicated, I just have to say the leftover amounts, the L values, are greater than or equal to 0 to avoid overspending. Notice that because the investments are variables, this checkbox will prevent them from being negative. But because the L cells are not variables, this checkbox does not affect them, so I have to explicitly say I want the L's to be non-negative. And also we always change this to the linear solver because we only have a linear constraint here. If we solve this, great. Here's what we get. First of all, as you know, because of scientific notation, these numbers simply mean a tiny little value, which for all intents and purposes we interpret as 0. This is not a bug, it's a normal thing that happens when computers are doing these kinds of extensive numerical calculations. They accumulate tiny mistakes, and things that should be a 0 come back as an epsilon, tiny little value. It's okay. Interpret them as 0. The conclusion is the most you can end up with these 4 investments over 6 years, if you begin with 50, is 70,245. So that 75,000 is not achievable, but at least I know that I got as much as I could. And the way this was achieved was by doing the following. Let's see, year 1, what did I do? Nothing in A1, nothing in B1. I put all my 50 in D1. That stays in there for 4 years, so I'm going now to the beginning of year 5. The 50 grows by 26% and becomes 63,000. In year 5, let's see, I did not put any money in A5, and I put the whole 63 in B5. I waited 2 more years. That 63 grew by, let's see, 11.5% and became the 7245. Okay, so the course of action is put money in D, wait 4 years, take it out, put money in B, wait 2 years, and you're done. It's reasonably simple because this is a small problem, there's not much going on. But if we start adding details to it, you'll see that it becomes, the course of action will involve more things. So let me give you an example. Going back to our problem statement here, right? The example they had here. What if I had extra inflows and outflows of cash? Let's say I have a bill to pay of 5,000 in year 3, another one of 2,000 in year 4, and I have an income of 3,000 in year 5. So it's a 5 outflows of cash and a +3 inflow of cash. How do we do this in this Excel? Basically, it goes like this. Well, math-wise, any inflow of cash that happens, you simply go to the year where that's taking place. So we have the inflow, according to the text, is in year 5, right? So we go to the have part of the formula of year 5 and just add that amount there. So I would put plus 3,000 in addition to these 4 things here. If it's an outflow of cash, for example, there were outflows in years 3 and 4, I go and put those amounts into the spend part of the formula. So inside this parenthesis, I would put plus $5,000, right? Because this is what I think was your first bill you had. Yeah, it's a bill of 5,000 in year 3, a bill of 2,000 in year 4. So inside the spend of year 3, I would put, in addition to these 2 things, you also spend 5,000, so plus $5,000. Inside the spend of year 4, plus $2,000. Right? That's how you change it in the math. And the equivalent change in the Excel is simply to go to the appropriate years. And in there, you say, well, if it's an expense, you add it as a minus. I'm going to also spend 5K. In year 4, I'm going to also spend 2K. So I added minus 2,000 to that formula. And in year 5, I'm going to get, so plus 3K So I put plus 3,000, right? If you want to do this in a more clean way, you could always, add an extra row here, add to it the inflows and outflows, and just make the formula refer to those cells. I'm just doing this to make it simpler for the explanation. Once I put that in, let's resolve. And now what this is going to do, and the beauty of all this is that you just have to add those extra numbers. You don't have to touch any of the other formulas. They continue to work just fine. So you just go back and simply click solve again, right? The conclusion will be the following. Now, before I was doing two things, right? Now, how many things am I doing in the optimal strategy? 4. I do something in year 3. I actually use B1 in year 1 in addition to D1. And I also do something in year 5. So I'm doing 4 things now, okay? As I said, as you add more details, the strategy becomes more complex. Great, so we saw how to do the original problem. We saw how to incorporate intermediate inflows and outflows of cash. The last thing I want to show you how to do is, what if I had a target value and today I have no money? I'm going to borrow money so that according to my plan, I want to have a given amount after 6 years. So let's say that given amount is 100,000. So what I'm going to do is this. This amount here then becomes a variable because it's a number I don't know. What is the least I can borrow today so that I have in hand, let's say, $100,000 after 6 years? So I'm going to delete this value from here. And I'm going to, just to really emphasize to you that this is a variable, I'm going to paint this gray like the others. Okay. Make it the same tone of gray. And I'm going to go in solver now and say solver. Before you were maximizing I-19, my ending amount. Now I want you to do this. I want you to minimize B19. So B19 is my objective cell. Instead of a max is a min. Minimize how much I have to begin with. Notice that in the variable range I have here from B5 to B18, but now I'm going to extend that to B19 as well, because again B19 has become an unknown number, a number that I want solver to find for me, a variable, right? So B19 is the objective and is also a variable in addition to the previous variables. And finally, I have to give it the target. See, I want this final amount to be equal to, and I'm just going to type it in here, 100,000. Right? So notice now what this is doing is it is incorporating all the investment opportunities plus those intermediate cash flows that I put before. They're still there. And now it's saying, tell me what I need to begin with so that when all is said and done, I will have 100,000 after 6 years. And if you do that, and you click solve, there you go. So what it's telling me is the following. If you want to have 100 at the end, which we got to, you need to begin with almost 75,000, 74,908. And this is the course of action. This is what you have to do with that $74,900 at each point in time, right? In year 1, you put some in B and some in D. You wait 2 years. That stuff that came out of B1, you put in A, right? And that is likely what you need to pay the bill in year 4. And then in B5, you get this money here, invest it for 2 more years, etc. Okay? So this is it. This is our cash flow example. As you can see, it can do some interesting variations of it. The math follows this nice pattern of have minus spend equal leftover. We're going to see that this pattern appears in other types of problems as well, like for example an inventory problem or production planning. And it's useful to have the ability to carry values through time, because lots of problems that have the passage of time, you need to keep track of some numbers as you go along, and this is the idea. All right. Hope this was useful and that this helps you understand the problem better and also build your spreadsheets. I'll see you later. Thanks for watching. Bye bye.